Hello Year 4, in today's maths video we are going to be doing statistics, which corresponds with week 8 of your home learning pack, and we're going to be interpreting some graphs and charts. So let's start off by looking at some key vocabulary. With the graphs and charts that we look at, they both might use different types of data. So we have discrete data, which is information that we collect that can be counted and categorized or put into groups. So for example, we might have a title that says favourite fruit in class 4, and the categories could be something like apples, oranges and pears. Discrete data can only use a certain number of values, as you cannot have half a child voting for apples or half a child voting for pears. Continuous data, however, is numerical data that can be measured particularly over time. So we might have, for example, the changes of height over time, or weight, or temperature. And we've got some more keywords at the bottom that we might come across. So we have axes, and an axis is the lines, the horizontal and vertical lines that we would see in a graph or chart. The horizontal line is the x-axis, and the y-axis is the vertical line. We have interpret, which means to read or find meaning in something. We have a key, and a key can represent different values, or it can represent two bits of information on the same chart. So in this one, girls are represented by the colour yellow, and boys might be represented by the colour red. And we've got a scale, and I put the scale vertically as a y-axis because that's usually where we might find a scale, and the numbers on the scale represent different things. So it could represent children, their votes, it could represent time. It depends on the chart or graph. And last but not least, we've got plotting or plots, and this is usually how we represent continuous data on a graph. For our first type of chart, we have a pictogram. Pictograms are a type of chart that use pictures to represent the data. And to make sense, a pictogram must always have a key. So this pictogram is labelled pocket money, and our key says that the £1 coin image does not represent one, it represents 9 children. So we've got 4 amounts. We've got £5 or less, 6 to £10, 11 to £15, and 16 to £20. And then we've got coins that represent the children that might earn that amount. Let's do the first one together, and then I'm going to give you a little go to have a go at the next 3. So for the first one, the £5 or less, we have 3 £1 coins. But it doesn't mean that 3 children earn £5 or less, because 1 coin represents 9. It means we need to do 3 lots of 9, or 3 multiplied by 9, which is 27. So 27 children earn £5 or less. Press pause now, work out the next 3 amounts, and then press play when you're ready to check your answers. Okay, press play. So for the next one, 6 to £10, we have again 3 amounts, so 3 images, which means 3 lots of 9, because 1 coin represents 9. So 3 times 9 is again 27. For £11 to £15, we have 2 coins. We have 2 of those £1 coins. So again, 2 multiplied by 9 is 18. So 18 children earn £11 to £15 of pocket money. And for that last one, we only have 1 coin. That doesn't mean that only 1 child earns 16 to £20. 9 children earn is represented as that 1 coin. So that means that there are 9 children that earn that amount. Okay, now it's your turn to have a go at this next one here. I'm going to read through the questions with you. We're going to interpret this pictogram together, and then you're going to have a go at answering some questions. So this pictogram shows the number of tickets sold each day in the week leading up to the Friday night school concert. Answer the questions that follow. So for the title of this pictogram, it's titled Tickets Sold for this Friday night concert. And our key, which is really important, states that this one image of a ticket doesn't represent 1 ticket, it represents 10 tickets. You've got 4 different categories: Monday, Tuesday, Wednesday and Thursday. And let's start with A. So A says, how many tickets were sold on Monday night? B says, how many fewer tickets were sold on Tuesday night compared to Wednesday night? And C says 65 tickets were sold Thursday night. Add this to the graph. So press pause now, have a go counting and working out the amounts of tickets for each category, and answer the questions, and then press play when you're ready. Okie dokes. So for the first one, how many tickets were sold on Monday night? So I'm first of all going to count how many images I have in that first row. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, ticket images, but it doesn't represent 9 tickets sold because one ticket, one image represents 10. So 9 lots of 10 would be 90. Okay. B, how many fewer tickets were sold on Tuesday compared to Wednesday? So because it's using that language of fewer and it's comparing two amounts, the operation we need to use is subtraction. So what I'm going to do is, first of all, work out how much there is on Tuesday and Wednesday, and then we can subtract it. So on Tuesday we have 1, 2, 3, 4, 5, and 5 lots of 10 is 50. And on Wednesday we have 1, 2, 3, 4, 5, 6, 7, 8. And 8 lots of 10 is 80. So 80 subtract 50 would give us 30. If you got that, fantastic. And the last one, 65 tickets were sold Thursday night. Add this to the graph. So first of all, I'm going to start by drawing out my images that represent tens. So that represents that one ticket. So we're going to count up to 60 in tens. 10, 20, 30, 40, 50, 60. And we've got a little fact here at the bottom that says, remember, you cannot have half a ticket. So we can draw the image to represent half, but the value doesn't represent half. The data is actually 5, isn't it? So we've got 5 tickets that have been sold. So if you've drawn 6 whole tickets and half a ticket, that is correct. Well done. Okay, now we're moving on to some bar charts. Bar charts are a type of graph that are used to display and compare the number of different discrete categories of data. Bar charts usually have a title. So in this case, our title is People's Favorite Pets. They have a horizontal axis that is labeled, and our horizontal axis is labeled type, or x-axis is labeled type of pet. So we've got different categories. We've got 5 categories: reptiles, dogs, cats, fish, and birds. And we've got a y-axis with our scale labeled number of children. And the first thing to do, especially when you've got a scale like this where there's missing values in between, a nice neat trick is to fill those values in. So between 0 and 4, we've got a missing space. So what is half of 4? It is 2. So let's count up in 2s to fill in these missing gaps. 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Okay, there are still some values that are missing in between, so between 0 and 2, between 2 and 4, and remember, we can't have any half amounts, we can't have any half values, so we need to keep that in mind. Okay, so let's look at the first question. We'll do the first one together and I'll give you a chance to do the next 3 on your own. First one, how many pupils prefer reptiles? Okie dokes. So first thing we need to do is look at the top of the bar, follow it along towards our y-axis, towards our scale, and see where it lands. Now our reptile bar is exactly in between 10 and 12. Our answer wouldn't be 10 and a half because we can't have half values, but it would be the next value after 10 that is just before 12, which is 11. So 11 children prefer reptiles. Have a go of the next 3 questions. I'll have a read now. How many pupils prefer birds? What is the least popular favourite pet? And how many fewer children prefer dogs to cats? So work those out and then press play when you're ready. Okie dokes. How many pupils prefer birds? So again, this we need to find it at the bottom. So we find birds, go to the right top of the bar and follow it along. You can use your ruler to follow it along exactly towards our y-axis. And again, it looks like it is right between our 8 and 10. So it's not 8 and a half, it is 9. 9 children prefer birds. Next one, what is the least popular favourite pet? Well, a good thing about charts is it's quite visual, so you can easily see from these 5 bars which one is the smallest bar, and that will help us work it out. You could also work out the number of children that voted for each one so that you're even more accurate with your answer. In this case here, the one that I can see that is the smallest is fish, as if we followed it along, it would land on 8 children, so fish. How many fewer children prefer dogs to cats? So again, that language of fewer, as well as it's comparing dogs and cats, which means we need to do subtraction. So first things first, we need to work out the amount of children that voted for each. So for dogs, it's right in between 18 and 20, so 19. And for cats, the top of the bar lands exactly on 18. So from 18 to 19, what is the difference? we have one child difference. Okay. And our last type of graph that we're going to look at, so we are looking at line graphs. Line graphs can be used to compare changes over the period of time, over a period of time for one or more than one group, and it often is used to represent continuous data. So let's first start off by interpreting this data that we've got in front of us. It is titled Temperature of Key Stage 2 Hall throughout the day in February. So we're looking at a change in temperature over a day. So over a day. Our x-axis at the bottom is labelled time of the school day, and it starts at 8 p.m. and it looks like it's going up in hours. So from 8 p.m. to 9 p.m. to 10 p.m. to 8 a.m. to 9 a.m. to 10 a.m. to 11 a.m. to 12 p.m. and so on until we get to 6 p.m. Okay, our y-axis is labelled temperature in degrees Celsius, and looking at the scale, it seems to be going up in 5s. Okay. So let's have a look at the first question together. What was the warmest time of the day? Give the hour and the temperature. It's asking for two answers in this one. It wants something from the x-axis and something from the y-axis. So because we're looking at temperature, we know that with temperature, the higher the value, the higher the number, that means it is warmer, the temperature is warmer. So I'm going to be looking at the peak of my, or the tip of my line, so the line that's, that we've charted here, and it takes us to right to the top here. We've got 3 points actually. So from 8 a.m. it started at 10 degrees, 9 a.m. it's gone up around towards 15, 10 a.m. just over there, and it goes up and it seems to be stopping right at the top. So we have at 12 p.m, 1 p.m. and 2 p.m. A continuous line. Okay. And what we need to do to work out what the temperature of this would be is, again, get our ruler, follow it along to our y-axis and see exactly where it would land. Because with this bit of data, we've not got that many markings in our actual scale, it can give us a little bit of room to give us approximate answers. So we're a little bit over 20, which means if you've given an answer that is approximately 21 degrees Celsius or 22 degrees Celsius, that would be correct. Okay, and if we were to interpret the rest of this graph, so it looks like it's raised. So from 8 a.m. the temperature is slowly increasing until 12 p.m, 1 p.m. and 2 p.m, where it seems to have stayed the same because there's not been much change at that time. And then slowly from 2 p.m. to 3, it drops down. It drops down and continues to drop down, which tells me that the temperature has changed as the day has gone by. Okay, have a go at the next two answers. So I'm going to read the next two answers and then work them out and press play when you're ready. So second question is, what was it colder at 9 a.m. or 3 p.m? And the last question is, what is the difference between the warmest temperature and the coldest temperature? So press pause, work it out, and then press play. Okie dokes. First of all, was it colder at 9 a.m. or 3 p.m? So before we do that, we need to work out the temperature of both two times. For 9 a.m, what I'm going to do is find that in my x-axis, and when I do that, I'm going to go up and stop where the plot is. So I've stopped exactly where it has been plotted, and I'm going to go across to the y-axis. So again, it's gone just under 15, so we can give an approximate answer here. I'm going to say, since it's it's really close to 15, I'm going to give it 14 degrees Celsius. I'm going to say it's around that amount. Okay, and let's do the same for 3 p.m. So I'm going to find 3 p.m. I'm going to go up and stop when I reach the plot, and I'm going to go right across, and it looks like it's just above 15. So I'm going to say that's around 16 degrees Celsius. So which one was colder? Colder would, in this case, would be a smaller number. Smaller digit would represent a colder temperature. And in that case, it is 9 a.m. Okay. And the next one. What is the difference between the warmest temperature and the coldest temperature? So again, we've already figured out what the warmest temperature was. We said it was 21 degrees Celsius, and now we need to find the coldest temperature. So similar to bar charts, in that it is the one that is the one closest to 0. We are going to look at each of the values closest to 0, and you can use that to check what the temperature is. In this case here, it is going to be, so if our warmest one was 21 degrees, our coldest one is this one right here, which is 10 degrees Celsius, and we need to follow down, and it says that's at around 8 a.m. So what is the difference between these two amounts? If we're doing difference, we're comparing, which means the operation we need to use is subtraction. So 21 subtract 10 is 11 degrees Celsius. If you got that correct, fantastic, well done. Okay, so that is everything. So for more statistic questions on interpreting different graphs and charts, check out week 8 of your Maths Home Learning Pack, and please keep up the hard work and effort. We really, really appreciate everything that everyone's doing. And yeah, well done.